Welcome to The Explainer. Let's just dive right into it and explore the terrifying new reality of autonomous AI agents, and more importantly, how we can actually secure them. Today, we're looking at a critical shift in artificial intelligence that is happening right under our noses. We are officially past the days of passive AI. Back when a hallucination was just a weird, funny sentence. Well, today, these agents take real-world actions. A hallucination now? It's a deleted database. It's an accidental rm-rf/command that can literally cause irreversible damage to your infrastructure. So, it begs the multi-million-dollar question: how on earth do we stop an AI from accidentally destroying our systems before it's too late? That's exactly what we're answering today by unpacking a totally groundbreaking new framework designed to intercept these disasters. Okay, Section 1, when AI agents take action, the new attack surface. We've entered an era where frameworks like Claude Code, Cursor, AutoGPT, they execute live tool calls. They aren't just drafting code for us anymore. They're actively running it, and this creates what's called an action time safety surface. Basically, a brand new vulnerability layer born from external side effects, like file operations or network requests. It's fundamentally different and, frankly, way more dangerous than anything we've faced with passive LLMs. You can delete a wrong word, but you really can't undrop a server, right? Moving on to Section 2, the missing layer of defense. Now, if the stakes are this high, you'd think our current security measures are keeping up, right? Well, actually, they're falling pretty short. Just looking at the landscape. Infrastructure sandboxes? They don't understand context. And post-hoc benchmarks? Those only measure harm after your system is already ruined. We desperately need a layer that operates in real time and understands the semantic intent of an action. And that is exactly where AgentTrust enters the chat. Which brings us to Section 3, inside the AgentTrust framework. Think of AgentTrust like an incredibly smart bouncer at a club, intercepting every single action before it executes. First, the agent proposes an action, which immediately hits the shell normalizer. This is our bouncer basically checking to see if a command is wearing a fake mustache. It uses pure text rewrite strategies to strip away obfuscations without ever actually executing the dangerous code. Okay, so once the command is stripped of its disguise, the action analyzer and policy engine take over. These two scan the normalized command against 42 distinct risk patterns and 170 configuration rules to understand its true semantic intent. They're hunting for the really severe threats, stuff like container escapes or database privilege escalations. With the intent fully analyzed, the trust interceptor steps in to orchestrate all of his data and issue a structured final verdict: allow, warn, block, or review. It uses a super strict confidence model, which ensures that the highest severity risk always governs the final decision. But, what if this situation isn't entirely black and white? If things get confusing or potentially dangerous, the system can call on the SafeFix engine to suggest a better path, or it can consult the cache-aware LLM judge for those really ambiguous edge case scenarios. And the coolest part? It only sends the newly added context to the LLM, which saves a massive amount of latency and compute cost. All right, Section 4, catching chained and hidden attacks. This brings us to the devious stuff, the methods agents might attempt through hallucination or malicious prompting. Traditional static rules? They would completely miss a disguised command. But AgentTrust handles these sneaky, obfuscated attacks by using pure text rewrites to just rip off the disguise, blocking the deletion before a single file is even touched. But what if an attacker gets really clever? Say they coordinate a multi-step attack, where each individual step looks totally innocent on its own. A simple file read, followed by an encoding step, and then maybe an external ping. Most per-call guardrails would look at that and allow every single step. And this is where the framework really shines. AgentTrust Session Tracker maps this out in real time. It watches the timeline of events to catch the exfiltration chain right before the data leaves your network. It literally connects the dots, from the sensitive read directly to the external post. Plus, rather than just aggressively blocking your agent and completely breaking its workflow, the SafeFix engine actually suggests safer alternatives to keep things moving. Instead of just stopping a dangerously permissive 777 command, for instance, it provides a safe 755 alternative for the agent to use. It's a real game changer. Let's look at Section 5, real-world performance results. So, we've established the terrifying problem and the theoretical solution. But does this actually work in a high-speed production environment? Well, yes. On a curated 300-scenario internal benchmark, AgentTrust's production rule set achieved a massive 95% verdict accuracy across 6 different risk categories. And it gets better. Against 630 independently constructed adversarial real-world scenarios, it hit 96.7% verdict accuracy. It caught over 93% of obfuscated payloads that would have completely bypassed naive pattern matching. Now here's the real relief for the software developers listening. The median end-to-end latency is an incredibly fast 1.72 milliseconds. That means it protects you without slowing down your interactive agent loops. It's operating at machine speed. Furthermore, AgentTrust is built with strict fail-safe contracts. If an API key is missing or an internal error occurs, it just defaults to review. This ensures the system never silently fails open, formally guaranteeing that a broken guardrail won't suddenly leave your network exposed. All right, wrapping up with our key takeaways. Agent tool use creates severe action time risks. Post-hoc testing and sandboxes are insufficient. AgentTrust provides real-time semantic interception, stops hidden commands and multi-step chains, and operates at low millisecond latency. Ultimately, every single action results in a structured trust report. This gives you explainable verdicts, exact rule violations, safety suggestions, and honestly, ultimate peace of mind. It's built perfectly for both automated pipelines and human security reviews. Because the question isn't if an AI agent will eventually make a catastrophic mistake on your system, but whether you have the bouncer at the door ready to stop it. As AI agents gain more autonomy, is your infrastructure ready to intercept their mistakes? Thank you so much for joining me on The Explainer today. We'll see you next time.